right, guys, let's go ahead and get started. You're going to see we're going to introduce a new concept. It's not a very new concept. It's a concept you already know, but we're going to start like working kind of backwards. And as we get closer to Thanksgiving, during Thanksgiving time, we'll go all out on them. So here we go. You guys ready? Let's chat a little bit about what an antiderivative is. Okay, well, just like the word says, antiderivative, it's, I guess you can call it like the inverse of derivative, or maybe reciprocal, no, inverse. Well, it's the inverse. Oh, you'll see. It's just going the other way. So look, check it out. You see these right here, all these three functions? Let's take the derivative of them. Y prime equals, what's the derivative of sine x plus 1? Yeah, that's cosine x. What's the derivative of sine x plus 10? Cosine x. What's the derivative? I didn't count how many zeros, but it looks like it might be a billion or 100 million, one of the two. What's the derivative of that one? Cosine x. Notice that all of them, regardless, had a derivative of cosine x, regardless of that c. So all the originals just differ by a constant. So if I were to do the antiderivative of cosine x, you would say y equals sine x plus some constant, because that constant can be anything. Does that make sense? So this is what you call antiderivative of cosine x. What's up? There is. There is a notation for it. I don't know if we're ready for it, but I will. Yes. All right. So the notation for antiderivative is an elongated s, and they'll have f prime of x. So there it is. And so let me go ahead and move this up. Oh, there was a way to highlight all of it. So y equals... All right. So here it is, guys. Here's your definition of antiderivative with notation. We will talk later on about what that elongated s means and that dx means. But here it is. There's my my symbols. What's up? Oh, yeah. Yes. Are we cool? All right. If you are super ambitious, because after today you'll have an idea of how to do antiderivatives. If you are super ambitious, there is a quiz. It's called UH quiz. It's called Antiderivatives, quiz 25. If you're super ambitious, you can start taking that quiz now. Not right now, because we still have a lesson. It's a short lesson, but it's a lesson nonetheless. All right. You guys ready? Now that we know stuff like that, it says here, find the antiderivative if you know that y prime is equal to 4x cubed. So I'm going to write y of x equals, so notice this says 4x cubed. So when I take the derivative, I need to get 4x cubed. What do you think the original was? That's it. And then I put a what? Plus c for some constant c. Does that make sense?
Yeah.
Okay. Okay. I'm doing it backwards. So is there a way that we can find antiderivative of any polynomial? Yes. So let's first talk about what we did to get a derivative. So let's see. If I have this, y prime, let's see the order that we did. We go 1 times 4, we bring that 4 down, and we subtract, and the derivative of a constant is 0. All right, so now let's reverse the order. Let's reverse the order of operation and do the opposite. Does that make sense? What do? Multiply and then subtract. So now we're reversing. So instead of subtract, we're going to add. And instead of multiplying, we're going to divide. So let's see if it works. So take that exponent. You add 1. So there's x to the 4th. And then I have a 4 here. And then divide by the exponent. And notice the 4's cancel out. Of course, you didn't need it for this one because that one was simple. Don't worry, I'm going to make up some questions. Y prime equals 2x to the third. There, a little more complicated. So what is y? Y equals, add 1 to that exponent. What is that? 4th, and then divide by 4, and then put plus c. Now see if it works. Y equals 2 and 4 reduce. X to the 4th over 2 plus c. If you take the derivative, 4x cubed over 2, 4 over 2 is 2, so it works. Do you guys see that or no? Yes, if I take the derivative, 4x cubed over 2 plus c, and if I reduce this, 4 over 2 is 2, 2x cubed. Oops, there's no plus c there. And there it is. I'll do another one. Y prime equals 5x to the 7th. I want y. Y equals 5x to the 8. I added 1. I'm doing antiderivative. Divided by 8. And then I put a plus c. Because the derivative of a constant is 0. And I could have any constant out there. And there it is. If I take the derivative of this, 5 times 8, x to the 7th, divided by 8, it goes back to 5. Because there's no way I can get 5x to the 7th if I were to take the derivative of this. Right? If I take the derivative, y prime equals 5 times 8, so you can see it, x over 7th over 8. No, you don't like that? If I take the derivative, y prime equals, what's 5 times 8? 40? 40 x to the 7th over 8. 8 goes into 40 5 times.
So in the previous one, I understood that one because
I made this question up, right? My derivative is 5x to the 7th, and all I said is, what's antiderivative?
Yeah, I know. But so in the previous one, you subtracted 1 and then you divided by.
No, I didn't subtract.
Sorry, you added 1 and then you
Divided by the exponent.
Yeah.
Yeah.
So you divided by the exponent.
Yeah. Yeah, working backwards.
I thought you divided by the total.
No, divided by the exponent.
Okay, so wait, are you saying that the y take the derivative of that 5x?
Yes. If I take the derivative of 5x to the 8th over 8, I will get 5x to the 7th. 5 times 8 is 40. X to the 7th divided by 8. 40 divided by 8 is 5.
You're right.
Okay. Are we okay, guys? Seniors, focus. All right, are we good? All right, here we go. These are the type of questions you will see in physics. You've probably seen them already. You do not need to use kinematic equations. You can do them all with calculus if you know a few general rules. The only rule you got to know is from position, you can get velocity by taking derivative. From velocity, you can get acceleration by taking derivative. So can you go backwards? Yes, you can. If you know the acceleration, you do the antiderivative, and that will get you velocity. You have velocity, and you take the antiderivative, and that will get you position. Does that make sense? All right. So remember how all these antiderivatives differ by a constant? So all I'm going to do is find that constant, and you know how to find that constant by what they give you. And don't worry, I'm going to do I'm going to do these 2 examples, and if you want, I can do more examples from the quizzes that you've already taken. So check it out. It says an object is dropped and hits the ground 3.5 seconds later. From what height in feet was it dropped? All right. All I know is that that my initial velocity is 0 because I dropped it, and let's see, what else do I know? I know it took 3.5 seconds for it to hit the ground. So let's write what we know. Let's see. This is movement on the y-axis. So I'm going to write y of 3.5 equals 0. Does everyone know why I wrote that? No, not initial. This is my final position. This is I'm saying that this is height on the y-axis. So it took me 3.5 seconds to hit the ground, right? So, or do you guys want me to use like s instead of, okay. So it's just motion on, when you see y or x, If you see x of whatever, that's motion on the x-axis, and y of t, that's motion on the y-axis. So in 3.5 seconds, my height was 0 because I'm on the ground. Does that make sense? Okay, my velocity at 0 is 0 because I dropped it. When you drop something, the velocity initial is 0. Correct. Are we still okay?
The velocity at 0 seconds.
Is 0, yes. 0, if you want to put units, let's see, this is feet, and this one is feet per second. All right, my acceleration at any time, t, is always, I'm going to say that acceleration due to gravity is negative 32 feet per second per second. If you want to write feet per second squared, that's fine. Are we still okay? All right, this is all I know. I just know that. I'm going to go backwards because they want to know what height was it dropped. I want to know y of 0 equals question mark. Because y is going to tell me my height, right? All right, so that's what I want. I want an equation for y. I'm going to go slow, guys. All I have definitively, 100%, I know that. Yes? All right, I'm going to do antiderivative of acceleration to get velocity. So I'm going to write do anti. When you see anti, that means antiderivative. So what is, let me rewrite a of t. A of t is negative 32, without the units there. You ready, Mazgeta? V of t, antiderivative. What is antiderivative of negative 32? Perfect, negative 32t, and I got to write plus c because there's some constant there. Did they give me something that I can solve that constant? Yes, they told me that my initial velocity is 0. So because I know that, I can say v of 0 equals 0. So I can go 0 equals negative 32 times 0 plus c, and I know you don't have to do all that. So from that, you can tell you that c is 0. Are we still cool? I probably should have written more space on this. That's fine. V of t equals negative 32t. This is my velocity equation. Are we still okay? All right, I'm going to go into this one. I'm going to write on the top border there. I'm going to get my position equation. And I'm going to do that by doing the antiderivative of velocity. So y of t is equal to, what's antiderivative of negative 32t? Let's see, add 1 to the exponent. This is the part 1. So 32, perfect. Negative 16t squared. And I got to add plus what? C. I'm going to find that C. I know that at 3.5 seconds, my height was what? 0. So I'm going to do that. Y of 0 equals, y of 3.5. Y of 3.5 equals 0. So I'm going to go 0 equals negative 16 times 3.5 squared plus C. No, C is not 0. C is a number. My height was 0. Yes. No, y is position. Y is position on my y-axis. I'm sorry, say it again. Yeah? I'm going backwards. No, you're good. You're good. Any other questions, guys? Okay. Remember that they told us that it hits the ground at 3.5 seconds. So my position on the y-axis at 3.5 seconds is 0. I'm just talking about motion on the y-axis. I'm either going up or down. There is no left-right movement. Are we still okay? Okay. So I put in my position equation. 0 equals negative 16 times 3.5 squared plus c. So it's obvious that you can tell that c has to equal 16 times 3.5 squared. So I take my calculator. You need a calculator. And let me clear that. 16 parenthesis 3.5, close it, squared, enter. Well, it was, but when I move it to the other side, it turns positive. So I got 196. That's what c is. Are we still okay? So my equation for my position on the y-axis is negative 16t squared plus 196.
Oh, and 196 squared was wrong.
I want to know from where it was dropped. So that means I'm looking for my position at time 0. Does that make sense to everyone? So I'm going to write y of 0 equals 196. So that must be the height that I dropped it from.
Oh,
Because I haven't dropped it at 0 seconds.
okay, yeah, that makes sense. It took me a second.
I wanted to find what height I dropped it from. And so I found the time at 0 of what height this was at. You know what I mean? Okay, they hit the floor at 3.5 seconds. Okay. And there it is. Done. Did we use a single kinematic equation? Nah. No physics equations anywhere. Well, I mean, if they know calculus, if they don't know. And you can't teach them to be robots because they need to know that a derivative is instantaneous rate of change. And, you know. All right, you guys ready? This is the one that I love this question because this will determine who really, really knows like physics and calculus-based physics and who doesn't. You can do this question with kinematics, but you have to do a hack. Or you can just do it with calculus, and there is no hack. You just do it with calculus. So give this question to Wentz, or whatever. Or we can do it later on with kinematics. You can do it with kinematics. Give this question to him, and he can do it. A falling stone is at a certain instant 120 feet above the ground. Okay, so a stone is 120 feet above the ground. They don't give us a time. They're being tricky. 2 seconds later, it is only 40 feet above the ground. If it is thrown upward with an initial speed of 3 feet per second, oh, he didn't throw it that high. He didn't throw it with a lot of force. From what height was it thrown? So it's probably going to be a number pretty close to 120. And I actually do already have the answer because I did it this morning. And I verified it by looking at the answer key from the UH. And I wrote it here in green. So the answer that we're supposed to get is an ugly number, 7735 over 64, which I did not check, but I suspect is really close to 120. I didn't check that because I didn't see what that number is. It is? Okay. Now, hopefully it makes sense to you that it should be pretty close to 120 because look at how much force he threw it up by. Did he put a lot of force into it? 3 feet per second? Did he put a lot? No. If it would have said like 60 feet per second or 100 feet per second, then I would expect this number to be a little larger than 120. So, whatever. No big deal. Are we okay?
Where are you getting 120 from?
Well, it said at a certain instant, he's 120 feet above the ground. If you only throw something with a little force, like it's not going to go much higher than 120. You know what I mean? Does that make sense? Okay. All right, here we go. All I know is the acceleration due to gravity. Is that what you know? All right, we're just talking about what type of motion? Up and down? And that's it. We're going to say, so let's see, what do we know? Acceleration due to gravity is negative 32. Make sure everything is in feet per second. Everything is. So make sure units, in physics they make a bigger deal about units. In calculus, we should be making a big deal about units, but all the units work right now. Maybe later on we'll try and trick you by putting something that's not have the same units. Are we okay? Okay, here we go. I'm going to do, let's write what we know. We know that at a certain instant, it's 120 feet. What instant is that? We don't know, so I'm going to write y of some moment. So I'm going to write t1. Usually you don't want to use t0 because t0 stands for initial. So you just want to go t1, t2, t3, whatever. So t1, at some moment, I'm at 120 feet. And then I know that 2 seconds later, so I'm going to write t1 plus 2. How many feet? 40. That's what we know. So there it is. I've written 3 things that we know. Oh, perfect. And I know that one. So let me write that one down too. Velocity at 0 is 3 feet per second. So we know 4 things. Are we ready? I think we're ready now. So I'm going to do antiderivative of acceleration. V of t equals, what's antiderivative of negative 32t, of negative 32, sorry. It's probably my fault. Just the number, negative 32. Antiderivative of that is
Negative 32.
plus c. Are we okay there? I have an initial velocity. You can, or if you can see it and you're super advanced, you can make the c already 3. If you don't see it, relax. V of 0 equals 3. So 3 equals negative 32 times 0 plus c. So from there, you can tell that c is 3. Cool? All I did was velocity initial was 3. And why is it positive and not negative? Because I threw this up. It says upward. If it was thrown downward, you would use negative. What's up? If it is thrown upward with an initial speed of 3 feet per second.
Also, when it's 0, it's supposed to be velocity.
Initial, yes. Are we, yes, Gomez.
What does the C stand for?
It's some constant. It's just some constant.
No, but like C equals 3. What does that play into?
Now I have a new velocity equation. My new velocity equation is v of t equals negative 32t plus 3. And now it works. When I plug in a 0, I get 3. Because that c is this c, right?
I think it's your starting velocity. I didn't have the equation where I don't know how it plays into like the whole rock throwing. Like what is it?
Well, it's just a constant. And so initially at 0, it's 3. And then at any moment after that, this is how you calculate your velocity. So if you want to know your velocity at t equals 1, you plug in a 1. Your velocity at 1 is going to be negative 29.
So it's a part, so you're saying like at 0, our velocity is 3.
Yes, because they told me that. So it affects everything because of your, if you just dropped it, then your initial velocity is 0. After 1 second, it's going to be going 32 feet per second, the speed. After 2 seconds, it's going to be going 64 feet per second. After 3 seconds, you just keep adding and adding. But because your initial velocity is 3, it affects it.
It's just gonna keep adding to it.
Yeah, what's up?
So if your velocity, if you're calculating your velocity at 1 second, you're going to get a negative number.
Yeah,
But you're throwing it up. So
it's already going down.
it's already going down.
At 1 second, yeah. It's going down real quick. You're not throwing it with much force. So you're only throwing it up. It's only going to go up for maybe like a fraction of a second, like real fast.
Oh, okay. So the 120 to like
That's how high you are at some moment. I don't know what that moment is.
so you're throwing it from higher up than ground level.
You're at least 120 feet above.
Oh, okay.
That's why I said it's not surprising that the final answer is not far.
I thought we were throwing from ground level, and somehow it was getting to 120 feet in less than 1 second.
No,
I was
they-
like, wait, that doesn't make any sense.
They want to know how high I threw it from.
Okay.
From what height was it thrown?
So
That's
you're
a-
like standing on a cliff or something.
Yeah, I'm standing on a building. Or, yeah, yeah,
Going on a tiny bit.
yeah.
Okay.
All right, guys. Do we understand the question? Okay, I'm on a building. I think it said we're in a building. Oh no, we're somewhere that's really high, and you're throwing something, and it's going above a little bit, just and then down. Okay. So there's my velocity. I want to know eventually what my height is. So I want to know y of 0. I can't get there until I do another antiderivative. Cool or not cool? What's antiderivative of this guy? So I'm going to write y of t is equal negative 16t squared plus 3t plus c. Here's where the magic happens, and you need your math skills. You guys ready? I have two knowns right here. And relax, it's not going to be hard. Chavez, I need another time value. Like, no, you don't. We're doing it with calculus. So I want to figure out, what do I want? Does everyone know that we want y of 0? Okay. So I need to plug in these things here that I know. I know at some moment, t1, I'm at 120, and some moment plus 2 seconds, I'm at 40. So I'm going to go ahead and do that. So I'm going to write negative 16, parenthesis, and let's do the t1. t1, close it squared, plus 3, parenthesis. Well, I guess you don't need a parenthesis there. Plus c equals 120. Does everyone see how we got that? Okay, here comes the next one. Here's equation 1. Negative 16, parenthesis, t1 plus 2, close it, squared, plus 3, parenthesis, t1 plus 2, close it, plus c equals 40. There's equation 2. Now what?
You know what this reminds me of? Wait,
No, if you say it, you're probably going to say it right.
is it the,
No, it's okay, but it's a safe space.
is it the X plus H thing? You know?
Yeah, oh, you're thinking about, yeah. I thought you were going to say systems. And I was going to tell you, yeah, this is a system. It's okay though. It's a safe space. We're good, miss. All right, here we go. Don't ever be scared. It's okay to be right or wrong or whatever. Like it's you want to talk about cake, that's fine. But here we go. I'm going to expand this because I want to, I mean, really, we're already done. We're just going to do algebra. I want to expand it in such a way I have two unknowns. What are the unknowns? T1 and C. And I have two equations. So any method that you can think of that you can do, will work. Whatever method you want. I don't really care about the time. I care more about the C. But it looks like we're going to have to solve for T anyways. It looks like to me. Because this is where we're at right now. All right, you guys ready? All right. So negative 16. And I'm just expanding this. T1 times T1 is T1 squared. Don't confuse your exponent with that subscript there in the bottom. Plus 2 times T1 plus 2 times T1. That is 4T1. Plus 2 times 2 is 4. And then plus 3T1 plus 6 plus C. All that equals 40. Are we still okay? All right, distribute that negative 16. And now I have negative 16 T1 squared minus 1632, 64 T1 minus 64 plus 3 T1 plus 6 plus C equals 40. Are we still okay? Okay, combine like terms. Negative 16 T1 squared minus, let's see, 64 and the 3. Is that 61? 61 T1 and then 64 and the 6 minus 58 plus C equals 40. And then last, move that minus 58 to the right. So negative 16 T1 squared minus 61 T1 plus C equals 58, 68, 78, 88, 98. 98. Are we still okay? This is your new equation 2. I have equation 1 and equation 2, and I want to solve for C. There may be other ways. But here's what I would do. I'm going to take equation 1, negative 16 T1 squared plus 3T1 plus C equals 120. And I'm going to take equation 2. Negative 16 T1 squared minus 61 T1 plus C equals 98. And I know that those C values are the same. And I'll wait for you guys to catch up. I'm putting parentheses. Those are parentheses. And I know that if I subtract these, I get rid of that squared and I get rid of that C, which for momentarily will be fine. So if I subtract these will cancel out. This will cancel out. And what's the difference? 3 plus negative 61, what's that? Negative, oh no, plus. Because I'm subtracting and adding, right? Minus a negative. So 64 T1 equals 22. I think that's correct. So I'm going to get my T1 value, divide by 64, divide by 64. So it looks like T1 equals 11 over 32. Are we still okay? All right. Now, I'll wait for you guys to catch up. Now, it does not matter what equation I use, because I should get the same answer. I'm going to plug that T1. By the way, if you're wondering what that T1 is, it's the moment when you're 120 feet up in the air. I'm going to plug that T1 into equation 1. And all I'm going to do is solve for C. Does that make sense? So I'm going to write, let me put it in blue, guys. I'm going to write negative 16 times 11 over 32. Did I write that correctly? Plus 3 times 11 over 32 plus C equals 120. So here we go. I'm going to take my calculator. Here's my calculator. Negative 16, open parenthesis, 11 over 32, close it, square it, plus, was it plus? 3 times 11 over 32, close it, enter. So I get that number. When I move it to the other side, that number turns into a what? Positive. So I'm going to scroll up. Let's see, can I turn? Oh, I'm just going to write it. 0.8593375. And I'm adding this to what number? And that should be my C, right? So there it is, 120.85. Let's turn it into a fraction. Here's a moment of truth. It sounds correct to me, but let's see. Math, fraction, enter. 7735. Look at that. Did we get it right?
So that's our C value.
That's our C value, which, by the way, because we wanted it times 0,
Okay. If they wanted it at a different time.
then we have a C that we can calculate it for any moment.
Okay, got it.
Wait, what do you mean?
Yeah, I want to know how high I threw this up. So I'm going to plug in the 0 in there. And if I plug in a 0 into my equation, I just get my C value.
Yeah,
That
what were you saying about like what would happen if it was any other number?
At any other moment, you just plug in the time that you want. Because this is my C.
Oh, okay.
You know what I mean?
Oh, so basically because it was a 0, like the negative 32 times 0 times.
Yes. Any other questions, guys? How do you feel?
Okay.
Do you think we can do the UH quiz related rates now?
I have some questions.
Okay. All right, so let's go ahead and see if we can tackle them. Hit me with the questions.